Hello everyone and welcome to lecture number 7. In the previous lecture we have seen H-plane T junctions. We are seeing the junctions, microwave junctions. We are seeing microwave junctions, and in the last lecture we have seen H-plane T junction. Okay, now in today's lecture we are going to see E-plane T junction. We are going to see E-plane T junctions. We are going to see E-plane T junctions. Now what is the difference between H-plane T junction and E-plane T junction? Is in H-plane you have a side arm. In H-plane you have a side arm connected like this, right? You have a side arm connected like this. While in E-plane we will be having in E-plane T junction you will be having such a diagram. Okay, this is the basic port, and over here you will be having another port, connected to it like this, right? Another port connected to it like this. Okay, this is the another port connected to it. This is port 1, this is port 2. This is being more congested. Let me draw it again. Okay, I think now this is clear. This is port 3. Okay, this is port 3. Now we can assume that port 3 as an input port, while port 3 as an input port, or port 3 and port 1 and port 2 as output port, and port 1 and port 2 as output port. This can be further connected. Okay, so this is port 3. This is port 3. We can assume port 3 as an input port, port 1 and port 2 are output ports, right? Port 1 and port 2 are output ports. Now again, let me take this to one of the side on screen, and let me rub everything to go ahead. For this E-plane T junction we will find for this E-plane T junction also we will find the relation between the A and B and scattering coefficient S. when over here, when remember you cannot have TEM waves traveling inside waveguide, transverse electromagnetic wave cannot exist. So when TE wave, TE10 mode is made to propagate into port 3 the two outputs at port 1 and port 2 will have phase shift of 180 degree. Remember, we will have phase shift of 180 degree since the electric field lines changes the direction, when they come out of port 1 and port 2, right? And it is called a E-plane T junction, and that is why it is called E-plane T junction. Now why it is having 180 degree phase shift? Let us see the cross-sectional view. The cross-sectional view of the port will be something like this. This is port 3, this is port 1, and this is port 2. The cross-sectional view will be something like this. If the input is from port 3, if this is an input, so electric field will be like this. Electric field will be like this. Okay, but the moment they start to detach, they will try to bend themselves, and at last they will bend like this. They will detach in this form. They will detach in this form. They will detach in this manner. So they will have 180 degree phase shift. Remember, this is not present in H-plane T, but E-plane T is having 180 degree phase shift between the two outputs at port 1 and port 2. Two outputs at port 1 and port 2. Two outputs at port 1 and port 2. Now again, since it is a 3-port junction, we will have 3 cross 3. We will have 3 cross 3 matrix. For scattering parameters, we will have 3 cross 3 matrix for scattering parameters. Let us see which are those parameters. The first one is 3 cross 3 matrix. We will have S is equals to S1 of 1, S1 of 2, S1 of 3, S2 of 1, S2 of 2, S2 of 3, S3 of 1, S3 of 2, S3 of 3. Okay? Number 2 is the scattering coefficient S2 of 3 will be equals to minus S1 of 3. Minus S1 of 3. Since the input port 1 and port 2 are, since this minus sign is due to that port 1 and port 2 are 180 degree out of phase. Okay? And port 3 is perfectly matched to the junction. So S3 of 3 will be equals to 0. We will not have any reflection. From port 3. It is perfectly matched. So it is having S3 of 3 will be equals to 0. So it will have S3 of 3 will be equals to 0. Okay? It will have S3 of 3 will be equals to 0. From symmetric properties. Now from symmetric properties, that is Si of j will be equals to Sj of I. Symmetric properties, we have S1 of 2 will be equals to S2 of 1, S1 of 3 will be equals to S3 of 1, and S2 of 3 will be equals to S3 of 2. Okay? With the above property, properties, we can have scattering matrix as S1 of 1, S1 of 2, S1 of 3, S1 of 2, S2 of 2, minus of S1 of 3, right? This is minus of S1 of 3, replacing S2 of 3 by minus 1 of 3. This is S1 of 3, again replacing by S3 of 2 by S minus 1 of 3, and this is 0. This is 0, right? This S3 of 3 of 2, this is equals to S2 of 3, and S2 of 3 equals to minus S1 of 3, minus S1 of 3. Now, again from unitary property, we have S dot S star is equals to identity matrix. That is, we will have S11, S1 of 2, S1 of 3, S1 of 2, S2 of 2, minus of S1 of 3, S1 of 3, S1 of 3, and 0. Okay? 0 not into S11 star S12 star, S13 star, S12 star, S22 star, minus of S13 star, S1 of 3, minus of S13 star, and 0 is equals to 1 0 0 0 1 0 0 0 1 is equals to identity matrix, is equals to identity matrix, right? Now again going for the expansion of this determinant, we can have first row, first column, first row, first column. We will have S11 whole square plus S12 whole square plus S1 of 3 whole square is equals to 1. Okay, this is equation number 1. From first row, second column, we will have S1 of 2 whole square plus S2 of 2 whole square plus S1 of 3 whole square is equals to 1. Equation number 2. Okay. This is equation number 2, and S1 of 3 whole square, that is third row, third column, S1 of 3 whole square is equals to 1. This is equation number 3. This is equation number 3, and we will have 2S13 whole square is equals to 1, therefore S13 will be equals to 1 by root 2. Remember this equation, S13 will be equals to, remember S13 will be equals to 1 by root 2. Okay? And moving ahead, we will have S1 of 3 dot S11 star minus of S1 of 3 S12 star is equals to 0. This is equation number 4. This is nothing but equation number 4. Okay, this is due to R3 C1, row 3 column 1, R3 C1, row 3 column 1, row 3 column 1. We will have S3 star. Okay, further what we can do is, we know that S13 into S11 star minus S12 star is equals to 0. Okay, S12 is equals to 0, but we know that this is not equals to 0, S13 is not equals to 0, therefore S11 minus S12 is equals to 0 and S11 is equals to S12. Okay, S11 is equals to S12. Again from equation number 1 and 2, we can write that from equation 1 and 2, we will have S11 is equals to S22. S11 will be equals to S22 and will also be equals to S1 of 2. S1 of 2. This is from this equation. S1 of 2 is from this equation. Okay. Comparing equation 1 and 2 as we have done earlier, for H plane we will get S11 is equals to S22. S1 of 1 will be equals to S2 of 2. Now using the above equation relation equation 1 will be S11 whole square plus S11 whole square plus 1 by 2 is equals to 1 plus 1 by 2 is equals to 1. Okay. Now moving ahead, we will have 2S11 whole square plus 1 by 2 is equals to 1. Therefore, S11 will be equals to whole square 1 by 4. Okay. 1 by 4 and S11 is equals to 1 by 4. Okay. If S11 is equals to 1 by 4, this is 1 by 4. S22 is also equals to 1 by 4 and S12 is also equals to 1 by 4. Right? Both will be equals to 1 by 4. Now, substituting all these values in our scattering matrix, 3 cross 3 matrix, we will be having S is equals to 1 by 2, 1 by 2, 1 by root 2, 1 by 2, 1 by 2, minus of 1 by root 2, 1 by root 2, minus of 1 by root 2, and this will be 0. We know that B will be equals to S into A. B will be equals to S into A. So, B1, B2, B3 will be equals to 1 by 2, 1 by 2, 1 by root 2, 1 by 2, 1 by 2, minus 1 by root 2. This is 1 by root 2, minus of 1 by root 2, and this is 0 into A1, A2, A3. Right? Into A1, A2, A3. This is nothing but what we have obtained. Substituting the values B, S and A. Now, obtaining the equations for B1, B2 and B3, we will get B1 is equals to A1 by 2 plus A2 by 2 plus A3 by root 2. Okay? B1 will be equals to how? That is first row, first column, first column. In the similar way, B2 will be equals to A1 by 2 plus A2 by 2 minus of A3 by root 2. B2 will be equals to 3 by root 2 and B3 will be equals to A1 by root 2 minus A2 by root 2. Okay? A1 by root 2 minus A2 by 2. A2 by root 2. Sorry. A2 by root 2. This is B3. Okay? Multiplied by 1 by root 2 into A1 minus 1 by 2 into A2. Minus sign is due to this negative sign. Okay? Now, we'll take over here also, we will take different cases. First of all, let us take case 1. Case 1, we will have A1 is equals to A2 is equals to 0, A3 not equals to 0. Okay? So what will be the value of B1? B1 will be equals to A1, A2, 0, 0, 0, so A3 by root 2. B1 will be equals to A3 by root 2. Similarly, B2 will be equals to minus A3 by root 2. B2 will be equals to minus A3 by root 2 and B3 will be equals to 0. B3 equals to 0. This is nothing but the values of B1, B2, and B3 with respect to the ports. And input at port 3 equally divides between port 1 and 2, but introduces a phase shift of, you can see a phase shift of minus is there, a phase shift of 180 degree. And E plane T is also act as a 3 dB splitter. Okay, E plane T also act as a 3 dB splitter. Okay, now going for case 2. Going for case 2, that is A1 is equals to A2 is equals to A and A3 is equals to 0. Therefore, B1 is equals to A by 2 plus A by 2 is equals to A. B2 will be equals to again A by 2 plus A by 2 is equals to A. Right? This is when port 1 and port 2 are as input and port 3 is 0. It's not acting as input. Okay? Then you can see that B3 will be equals to A by root 2 minus A by root 2 is equals to 0. Means if you apply input at port 1 and port 2 of equal amount, then you will get 0 output at port 3. You will not get output at port 3. That is equal input at port 1 and 2 results no output at port 3, right? Results no output at port 3. Now the last case, that is case 3. Case 3, we will have A1 not equals to 0, comma A2 is equals to 0, comma A3 is equals to 0, and we will get B1 is equals to A1 by 2, B2 is equals to A1 by 2, and B3 will be equals to minus of A1 by root 2. Similarly, we can have all combinations of input and output. Okay, so this is all about the E plane T junctions. E plane T junctions for microwave junctions. Okay, thank you.